Okay, let's now look at the volume of the pyramid compared to the volume of the box, or the cuboid. This shape here, which is a box, as we usually consider it, box there, is sometimes mathematically called the cuboid. Like a cube, but there is no necessity for the equality of the lengths of the sides. So a cuboid or box. Okay, suppose that we have got a pyramid here with a base that is identical to the base of the box there. So suppose that this base here has got an area A, and that base here has got an area A. Let's use another color. This area A and this area A. And suppose that the height of the box, h, is the same as the height of that pyramid, h. We would like to compare the volumes of the box and the volumes of the box and the pyramid. First, we have studied before that the volume of the box there, the volume of the box or the cuboid, is just length times width times height. Okay, length times width times height, length, width, height. But the length times the width is just the area of the green base. Length times width is just the area of that green base there. So the volume is just length times width is just what we call A, the area of the base, which is in red there, multiplied by the height. Great. This is the volume for the this is the formula for the volume of the box. For now, let's look at an animation that is similar to the one that we looked before for the comparison between the cone and the cylinder. We have got here a box, and that box contains a pyramid. That pyramid has got a base that is square, that is identical and congruent to the base of the box, so to speak. Okay, now we can view the height of the box that is to be similar to the height of the pyramid. Notice that this point, the top point of the pyramid, just touches the top of the box. So the pyramid and the box have got the same square base. They have got the same height, as discussed here in the diagram. Okay, so now, as we did before, with some mathematical proof, we can show that the volume of that pyramid is just 1/3 of the volume of the box that contains it. Here we can see that there is a box that contains that pyramid. They share the same square base and the same height. So, okay, what is the volume of the box that contains that pyramid? Oh, here is it. The volume of the box is just the area of the base times the height. So the volume of the pyramid there will just be 1/3 times that thing. So whenever you have got a shape like a box that contains a shape like a pyramid, the volume of the pyramid is just 1/3 of that volume of the box. Similarly, the volume of the cone is just equal to 1/3 of the volume of the cylinder. Okay, so let's take an example. Where is it? Okay, suppose that I have got a pyramid there with a base that is a square. Suppose that there is the top of the pyramid in red there, and I'm gonna draw the sides of the pyramid. I hope that you can see this. Great. Suppose that length there is just 10 meters in that case. That width there is 6 meters, and the height of the pyramid, suppose that it is, not this. The height that is perpendicular to the base, there must be a 90 degrees there in order to consider this as the height. So this is considered as the height when this is 90 degrees. Okay, suppose that this height is just 20 meters. And we wish to calculate the volume of the box, of the pyramid. Okay, as we did before, the formula is just volume is just 1/3 of the area of the base times the height. Okay, 1/3. The area of the base is just length times width, so it's just 10 multiplied by 6 multiplied by the height. What is the height in that case? It's just 20. Okay, 1/3. You can calculate all of this in your calculator, or you can do it in your brain. Just 1/3 10 times 6 is just 60 multiplied by 20 there. So this 60 becomes, sorry, this 6 times 10 becomes 60. And then you just can write 60 divided by 3 is just 20. And multiplied by that 20 there is just equal to 400. Or you can just plug all of this from the beginning on your calculator. 400 what? What was the unit here? It was meters. There it was meters. There it was meters. So the answer must be meters cubed. That's how we look at the volume of the pyramid. Finally, let's move there to discuss the volume of the sphere. There is no proof to be given or any comparison regarding the volume of the sphere. We just define the sphere to be a ball, just a ball, three-dimensional ball, like any ball from our everyday life. So suppose that this is the center of the ball, sorry for that, and suppose that this is a point on the boundary of the ball, so this must be the radius. So if we are given the radius of the sphere, then the volume of the sphere is just equal to 4 over 3 multiplied by pi multiplied by the radius to the power of 3. That's it. Just you need to memorize that with no proof to be given at that stage. Okay, an example. Suppose that there is a sphere of radius r equals to 10 meters. Okay, find its volume. Okay, according to the formula, the volume is just equal to 4 over 3 pi times r cubed. What is r? Just 10, so 10 cubed. Okay, 4 over 3 times pi times 1000, and you can just plug all of that or all of that from the beginning on your calculator, and you will be able to find the volume. That's it.